Good morning and welcome to LinuxLab. I'm Alessio Lama and I'm an embedded developer in a developer company. In my professional life, I worked with network and safety devices. In this talk, I will explain the major issues related to the development of a network protocol for safety application. There are more protocols that can be interfaced with the industrial PLC, programmable logic controller, like Ethercat, Ethernet IP, PowerLink, Profinet, etc. But to use them, we need to pay license, and we can't really modify the source code. If you want to develop independent devices without PLC communication, then can be useful to develop the protocol in the company to adapt it to your needs. Now I show you some fields application. Can be interesting automotive. Considering that today we need to create communication from Linux graphic user interface in the vehicle dashboard to engine control unit. So we can see velocity, round per minute, diagnostic lights, etc. For the industrial automation, where we need to configure and monitor the state of the embedded devices, and sectors with the same needs, like biomedical, avionic, and generally where we need to interface to safety microcontrollers unit. The physical levels more used are Ethernet, that can be extends the cables for many meters in the industrial building, and CAN-bus, especially used in the automotive sectors. Sometimes, in many cases, those systems are real time. What are the major issues? Major issues to consider are access denial, restrict access from the external network, because some hackers could interfere with the normal operation of the device, and this could be dangerous for the safety of the people. The network is not deterministic. There may be electromagnetic interference or bugs in the net drivers. Then it's better to take precautions regarding losses, repetitions of frames, corruption, and in real-time cases we need precious timeout for the response of the request. Now we will see the access to the network. Before to develop, it's better to analyze the network topology that we will need, like ring, mesh, star, fully connected, line, tree, or bus. In those applications are more used bus, line, and ring with daisy chain connection. This is useful because in the industrial building we need to install few cables, then you can have a low cost. Depends from your network configuration how the external access will be designed. In a distributed system, it's good to have a master device responsible for the communication with the external network, and it sends requests to slave devices. In this way, there isn't direct connection from the external network to slave devices. This can degrade the performance, but the safety is more important in this case. For this, we need VLAN, virtual local area network, to isolate them at the data link layer, level 2 of ISO stack. We will configure correctly the hardware switch to bind the port with the associated VLAN, and if possible, set the priority of the switch queues. VLAN is simple. Is an header next to the Ethernet header that describe the ID of the VLAN and the priority. Of course, this is not enough to limit access. You can create rules to block input traffic from not authorized MAC address, or you can limit the data rate. I show you some commands in Linux just for create a VLAN on Ethernet 0 interface with 8 ID, and you can create an IP tables rule to accept the traffic from certain MAC address. But you can add an option like limit to set the max data rate in input or output. If you know IP tables, you have many possible configurations. What kind of protocol you need for this? The polling protocol is the right mode to communicate in the client-server architecture. Any request require a response or an acknowledge from the server. The frames must contain a unique ID to identify the kind of request, a sequence number to identify repetitions and lossless frames, a signature to check the integrity of the data, and a timestamp is more useful if we are talking about real-time systems and other data that depends from your application. Corruption is simple. Now I will talk about the signature. There are more algorithms to check random errors, data corruption, but each one have its overhead and security. The Ethernet controller calculates and checks CRC, but the redundancy helps us to be sure in the safety applications. CRC, cyclic redundancy check. We can have CRC 16, CRC 32, CRC 64. Depends from what security want to check. as a CRC has low overhead, and it's simple to perform on microcontrollers units, then is suitable for this. On the contrary, SHA and or MD5 makes more overhead, and then it can introduce relevant latency for the processing of the real-time systems. I prefer to use that for the security checks. For safety systems, CRC is suitable. Interface disconnection. The devices have to be disconnected and connected during the normal operation without resetting or production chain. Then it's good that the master device can detect the correct connection of the slave devices with the supervision packets to realign the sequence number. This technique is used in the PRP protocol that we will see it in the next slides. This is a normal, a simple concept that when you replace a device in your industrial building, if you stop the chain, you lose money, you lose pieces in your daily production. Timeout, like any protocol, like HTTP, you have a timeout in the communication. To diagnose the timeout failure of the server response, simply the client implements a callback timer, and if necessary, we can compare the request timestamp with the response timestamp synchronized with the PTP protocol, precision time protocol, used in more industrial safety application. Okay, to synchronize the machines. But more hacker, some hackers can sniff your communication, and then you can do something. The network can be encrypted with some algorithm like advanced encryption standard. For example, I showed you for low data rate, you can use a length key like 256, and for high data rate, you can use a key length like 128. For high data rate, that key is not very secure, but you can't have the maximum security in this case, because the performance are so important in real time system. Then I can't. Is not recommended in real-time cases because could introduce considerable delay in the data processing. For example, like data rate is like video streaming. If you want, for example, if you want to encrypt the video streaming, you can use that. But if data can't be encrypted, we can make complications in the sniffing of the hackers with the bit masking. Okay. For example, in Canvas network, 1 byte that describes the round per minute can be split to 2 frames with a different ID. Or in output, multiply constant float, in input, divide constant float. Those kinds of codification are already used in some naval standard like J1939 or in automotive because those sectors use microcontrollers that have small performance, and don't have encryption peripherals. Okay, and this is a mode to to make complications in the sniffing activity. Okay. Now I want to show you some tools to work in Linux or other OS, because are tools developed for all OS. The first is the best famous sniffer, Wireshark. All people know Wireshark, but not all. To debug and test our protocol, we need powerful and reliable tools, and Wireshark is one of those. Wireshark was born 1999 when his name was Ethereal. It contains dissectors for all standard protocols, also for wireless networks like GSM, Bluetooth, Wi-Fi. What is the key of this work, of this job? The filter is the key to sniff and create a good and readable report. It's possible to filter MAC address or IP, destination address or source address, specific protocols, and use specific parameters of the protocol to filter the packets. For example, the port of the TCP. You can decode encrypted packet if we have the key, or read statistics. What you want about analyzing network and debug it. But now I'm talking about a new protocol, a custom protocol that Wireshark don't have the dissector for your new protocol. That we have to create a dissector for it. What is a dissector? Dissector is an extension of Wireshark that can be written using languages like Lua or C, and it defines the rules how to parse the raw frame and print to video readable informations. This is a link to Wireshark documentation, how you can develop your dissector. This simple code written in Lua declare a mu protocol. The name of this mu protocol is myproto. Okay, and I want to show, and this protocol is on the 8002 port of the TCP. We want to show some parameters like the command parameter and the data parameter. Okay, just simple, just for example, but you can do what you want. And this is the output of the sniffing. As you can see, my proto is written on the top input bar that is needed to filter the packets of my proto protocol. Or I can append in the bar and IP.addr equal the IP what you want to only show the packets received or sent to a certain IP. And you can see command and some comment like command that is here or in the tree below, and this is very useful because you can image normally if you don't have a dissector, you will see only raw data, and is not readable. This. Okay, Wireshark have more features that I need 1 week to describe all features of Wireshark, but this is important to develop a new protocol. Another tool is Scapa. We have to consider that we need also a packet crafter to send custom packets to the network for simulate the normal operation or fault insertions. Fault insertions are important because to certificate some real-time system, you need to show the reaction of the system from fault insertions. For this job is useful Scapa. Scapa is a tool written with the Python language. It contains the support for more standard protocols. We can manipulate frame at any ISO-Z levels and insert the headers and the data that we prefer in the packet. At any level, you can create a frame with a fake MAC address. You can use this also for hackers activity, but if you know the new network controller add the true MAC address to the packet in any case. But if you if you buy some some USB network controllers, you can bypass this this issue. Okay. Also for Scapa, we need to know how to work with it to develop a custom protocol, and for this you need to declare a new class that inherit packet class. This is a Python syntax. Disney class inherit packet class, and declare the fields of the packet. Okay, you can use this class next the Ethernet headers, or next the IP headers, or next the UDP headers. What you want depends from your application. Remember that the IP stack is so slowly in some real-time application. Then we prefer to create a protocol at data link layer. We can create the dissection rules, but with Scapa, but I prefer to do that with Wireshark. Scapa just for send and create custom packet. Wireshark to receive, sniffing the information. But Scapa is a powerful tool that you can do what you want with Scapa, also in receive mode or in sending mode. Just for an example, the class have the show method to show the parameters, or you can see the raw data, and you can see the types. Scapa have custom types that you can will see in the Scapa documentation, good documentation, and okay, this is for debug for debugged systems, but you have to develop a test suite. Okay. To create a test suite is an important point of development. We can use more framework tools to test a program, but TTCN 3 testing and test control notation version 3, written by European Telecommunications Standard Institute, used in conformance testing of communicating systems like 3G, LTE, and it's promoted from automotive project AUTOSAR. TTCN can be integrated with types systems of other languages like ASN.1, XML, C, C++, and if you search on the web, you can create some binding. TTCN, to use TTCN, you have to declare a test system. TTCN have to know how your system is organized, okay? And you can use platform adapter. Platform adapter are the Ethernet interface, wireless interface, to connect the TTCN tool to your system under test. Okay, SUT. This is the notation for TTCN, and you can have some API for logging the test, and I show you now just a simple example. How many people know TTCN? Okay, it's I know that. Okay, this is a simple example where you declare a test system and one test case. Okay, what is a module? The module is the top level container in a test suite. Okay, and in this module you declare the type, you declare the component, that the component is an execution entity, and the components communicate with each other or with the system under test through ports that are mapped to each other. Okay, and you can create a template that define the values that we want to control in the request or in the response, and then you can define the test case. Okay, and you can see that the test case is associated to a component as system. Okay, and you can have alt. An alternative is like an if. Okay, and I send the request, and I have two alternatives. All is okay, or the verdict is fail. TTCN have this type verdict that is not only pass or fail, but you can have known, pass, inconcluded, fail, or error. If you used some test suite for field bus like Profinet, you can remember this type of verdicts. Okay, those are the tools to work in Linux or in another OS. But if you develop a safety system with Windows, you are a crazy man. Okay. And some protocols interesting to develop our communication. This is external. This is external from your custom protocol. Is just to have a good timestamp in your frame. PTP, Precision Time Protocol, is a protocol at application level to synchronize the devices in the industry. Master device send sync frame to synchronize the clock of the slave devices, and to have a good precision, it calculate the delay of the request and of the response to calibrate the system. Okay, because I can have slave devices very far, sometimes 200 meters, and there is a relevant delay, okay, and this system of delay requests that calculate the time of the response before the syncing is good to create good precision, okay. This is used for synchronize servo of the motors in the industrial automation, but you can do any things when you need a good timing in your real-time systems. You can use software timestamping provided by the kernel, or hardware timestamping provided by network controller. In the second case, the precision is better. Anyway, it's about microseconds. It's possible to implement at IP level or data link level. Naturally, at data link level is better, okay. And I show you for Linux, we can use official package, Linux PTP. These work both master and slave. Before configuration, it's good to know the available capabilities, okay, because more network controllers are not support the hardware timestamping, okay. And next, we can use a configuration file to specify the network interface, the modality, hardware or software, and the log level. There are other settings, but those depend from your application. There are some settings for the servo, for synchronize the servo, with for example also for Raspberry, and on the Red Hat site you can see more information about it. PRP is not famous, PRP, but is an important protocol for the redundancy. The redundancy is important in safety applications. PRP, parallel redundancy protocol, how work? Redirect the packet on two network interfaces. So, if you will be a fail on one of those, anyway, the system can work correctly. This allows us to have a very strong communication. I think this is very useful in wireless network, but officially is not supported for those kinds of networks. But I have fixed the source code to make it possible, starting from the kernel driver inside the processor SDK of Texas Instruments. Yes, because in the mainline kernel this is not available. There is a brother of PRP is HSR, but HSR work in ring mode. Okay, PRP is point and is so complex. HSR is not useful to use HSR if you need just a simple redundancy. Okay, and the only documentation to work with that protocol in Linux are on the site of Texas Instrument. But remember that if you want to work with this, you have to make a porting for your kernel. Okay, but if you want some advices, write me. I can help you. How work? It's add an header in the frame next Ethernet header that contains the reception LAN and the sequence number. So veramente? 45? Ho finito. So the receiver can understand if the frame is already received and then drop the duplicate. Exists a drop window that describes what frame passed have to drop. Configure this parameter is useful to calibrate your system dependent from the data rate value. Okay, and this is all. Thank you for your attention.
Thank you, Alessio.